Hey fellow problem solvers, Colfax Math here. Today I'm going to go over univariate and bivariate stats, some of the important things to note, what the difference is between the two, and what variables you look at in between the two different statistics. This is for an IB Math course, Analysis and Approaches, SL Chapters 6 and 7 in the textbook. Univariate stats means only one variable. Usually you denote that variable as x. So let's say we are looking at grades in the class. The first number you want to look at in univariate stats is the average, represented with the x bar. The way you find the average is you add up all of the values and divide by the number of values. So that's a Greek letter sigma, meaning add all of them up. Of the values, divide by the number of values. That's also called the mean or the average. Sometimes you look at the median. The median is the middle number. So if I have grades that say 75, 80, 85, the average, I would add up all three, divide by 3 and get 80. And in this case, the median would be the same. The median would be the 80 as well. If I had, say, 4 values, another value of 85, then the median would be the average of these two. So the median in this case would be 82.5. The mode is the value that appears most frequently. So if these were my test scores, the mode would be 85 because there are 2 values of it. So these are measures of central tendency. The other thing you look at as well is how close the values are to the average. And that's called a standard deviation. That is also a Greek letter sigma, but a lowercase sigma. So this is standard deviation, and it is a measure of variability. Sometimes you also look at variance, which measures variability. It is lowercase sigma squared, and that's variance. But if you have the variance, you usually just take the square root to get the standard deviation. A deviation is the difference between the actual value and the average value. So you're looking at how well clustered the data is around the average. So one more time, univariate stats is all about the average and how close the values are to the average. Now let's take a look at bivariate stats. So in bivariate stats, we're looking at 2 variables, usually x and y. So let's say we want to look at how hours of studying affect grade. So hours of studying and the grade in the class. So one is dependent on the other. So does your grade depend on hours of studying? So y would be your grade because it depends on hours. And then I would collect all my data, x and y. X would be hours of studying. Y would be my grade in the class. I could assign numbers however I wanted, 90, 80, 70. And I would graph all that data. And I would see if there was a trend line. And then once I found that data, I would create that trend line, put my trend line on top of my data, and see how good of a fit it was. This trend line, or called a regression line, is usually referred to as y prime. It is a model to see if there's a relationship between the data. So let's say this is a linear regression, y equals 3x plus 5. I want to know how good that model is. A lot of times you use a correlation coefficient represented with an r or a lowercase r. That is your correlation coefficient. And it is measuring how close the data points are to your model. So again, in univariate stats, you're looking at how far your data is from the average, and there's only one set of data. Here you're looking at correlation between 2 variables and their relationship. Does studying actually affect your grade or not? Well, you check the accuracy of your regression line with the correlation coefficient. If r is close to 1 or -1, then it is a good fit. A bad fit is, say, 0.6, 0.5, 0.4. A 1 is perfect fit. This is direct correlation, a positive slope. -1 would be inverse correlation, a negative slope. Sometimes you take that value and you square it, called r squared. It's going to highlight your bad correlation a little bit better, because if your correlation coefficient were 0.9, you square that, it's now 0.81, and it makes it all positive. So r squared value closer to 1 is a better fit. The difference between your actual data point right here, this would be its y value, the difference between y and the model, that vertical distance is called a residual, and it's y minus y prime. So in univariate stats, you're looking at a deviation, the difference between your value and the average. In bivariate stats, you're looking at a residual, and you're figuring out how far the data point is from the model. You can find all of these stats on a TI-84 graphing calculator under the Stat button. You'd edit it, enter your list first, then you go to Calculations. You could run one variable stats and get this out. Or you could enter both sets of data under Bivariate stats. You'd enter list 1 and list 2 in your graphing calculator. After you put all your data in there, you could go down to Calc, and you could run multiple regressions. Some of the common regressions you run are linear regression, nth power regression, exponential regression, or quadratic regression. You could run all of those here. If you are not getting an r squared value when you run that regression in a TI-84, you go to Catalog down here, that little blue button, and under Catalog, you turn the diagnostics on. And then when you run your regression, you'll get an r or r squared value. So when you're doing an experiment, you figure out, am I just collecting one set of data? Well, then I'm just collect all that data. I might collect it in a frequency distribution where I have the value x and how often it occurs, the frequency y. And then if it's only one set of data, I'm doing univariate stats. I'm going to look for mean, median, mode, standard deviation, maybe draw a histogram of that data, look at the quartiles, upper quartile, bottom quartile, interquartile range. That's all in the univariate stats. Or if I'm trying to figure out a comparison or correlation between two different variables, then I would be looking at bivariate stats. I'd figure out which is independent and dependent. I would collect all that data, graph that data, run a regression on that data set, and figure out whether or not there was correlation. And the measure correlations with an R value. Another way is to do the residual sum of squares, but really what an R value is finding is how far all these data points are from my model. And maybe that blue line's a pretty good fit, but if I ran an nth power regression, maybe it would be a better fit. So you run multiple regressions, you check all our R values, whichever one's closer to 1 or -1, the better the fit, and that's the regression you pick. So hopefully it's a good overview of the difference between univariate stats and bivariate stats and the important variables that you're going to use in each. Thank you for watching.